So, thanks to one of the students, you know who you are. They just watched section 2.3 and they said, hey, that last example where you have all that annotation, is it working? Also, don't forget the squeeze theorem's missing. So, I knew about the squeeze theorem. I didn't know that example 9 wasn't there anymore. So, I'm going to try recording it here on my home computer. Hopefully you guys can follow along with me. Oh, we'll just have to see how it goes, right? I'm just going to forcefully white knuckle fine about all of this. Okay. Let's take a look at this example here. This example is pretty cool because it has an absolute value function. And the absolute value function is defined as a piecewise function. So I'm trying to find the limit if it exists. What that means is I'm going to find the left-hand side limit, and I'm going to find the right-hand side limit. So I'm going to find the limit as x approaches -6 from the negative side, and I'm going to look at the limit as x approaches -6 from the positive side. So let's do that. Keep in mind, the left and right hand side wouldn't normally be different except for the fact that I've got an absolute value here. So that's going to change what I'm using. Keep in mind that the absolute value of x equals 6 is like saying -x minus 6 or x plus 6. Depending on whether you're smaller than 6 or -6 or greater than -6. And then they meet in the middle there when x is actually equal to -6. So if I were to do the left-hand side limit, I would look at the limit as x approaches -6 from the left of this 2x plus 12 all over the absolute value of x plus 6. But since this is the left-hand limit as I'm approaching from the left side, I am going to use this definition for the absolute value. Let's make that substitution. So limit as x approaches -6 from the left of 2x plus 12 divided by -x minus 6. All right, well, let's simplify. In the top, I can factor out the 2. And in the denominator, I can factor out the -1. And what's cool about that is once I do those actions, I can cancel the x plus 6. And I end up with the limit as x approaches 6 from the left, 2 divided by -1, which gives me -2. All right, so the left-hand side has a limit of -2. Now let's do the right-hand side. So the right-hand side is the limit as x approaches -6 from the right of the 2x plus 12 all over the absolute value of x plus 6. Now, because this is the right-hand side and I'm approaching -6 from the right, I'm going to use the right-hand definition for the absolute value. I'm going to use x plus 6 instead of the absolute value of x plus 6. So let's make that substitution. So the limit as x approaches -6 from the right of 2x plus 12 over now just plain Jane x plus 6 because I'm using that right-hand definition. I'm going to factor again. I can only factor the top this time. But cool stuff does happen. My x plus 6's cancel. And I am left with a right-hand side limit of positive 2. Well, uh-oh, what do I notice? Those two things are not the same. Okay? And when my left-hand side limit doesn't equal my right-hand side limit, then I can say that the limit at that point of -6 of this original function does not exist. And that's my final answer. Let's take a look at the squeeze theorem. So here is the squeeze theorem. Imagine that you have a friend named Harry. And Harry is what you would consider that super extra friend. Harry's very outgoing. Harry sometimes makes questionable choices. Harry is always the life of the party, maybe too much of the life of the party. And then you have your other friend, Francis. And Francis is not like Harry. Francis is super chill. In fact, sometimes a little too chill. Doesn't always have as much fun, is kind of, whatever, having a hard time. But, it's just very chill, maybe even to the point of lame. Well, these are your friends because they kind of keep you honest, right? Here's you, G. You're pretty much always between them. You never get as crazy as Harry. You never get as chill as Francis. However, if you're always less chill than Francis and less extra than Harry, if there's some party A where they're both at the limit L, you're going to be at that limit too. In other words, if Harry is telling you to chill out, you should chill out. If Francis is telling you, you should liven up a little, you should liven up a little, right? Yes. So this is the squeeze theorem. So basically, you, G, are in between super chill Francis and super extra Henry for all values on your interval. And then, even if you can't find your limit, if you know Francis's limit and Harry's limit, then you know your own. This is called the squeeze theorem. An easy way to demonstrate this is as follows. So here you have some undefined function f that is in between 3x and x cubed plus 2. If you need to find the limit when x approaches 1, what you want to do is you want to plug in for each of these functions x equals 1. So you'll get 3 times 1 on one side and 1 cubed plus 2 on the other. Notice when you plug it into both of them, you get 3. So that means, since f of x is in between them, that the limit as x approaches 1 of f of x must also be equal to 3. And that is the squeeze theorem.